kickstart with the door opens first, and then we'll close later if that's fine with you, Doctor. Yeah?
Okay.
Excellent. Okay, ladies and gentlemen, let us now begin. I would like to first introduce our speaker, our next speaker. Dr. Stefano Zanero received a PhD degree in computer engineering from the Politecnico of Milano Technical University, where he is currently spending his postdoctorate. His current research interests include the development of intrusion detection systems based on unsupervised learning algorithms, security of web applications, and computer virology. He is a member of the board of the Journal in Computer Virology and acts as a reviewer for the ACM Computing Reviews and IEEE Security and Privacy, as well as various primary international conferences. He is a member of the IEEE, the ACM, and a founding member of the Italian chapter of ISSA. He has also been a columnist for Computer World Italy and has been awarded a Journalism Award in 2003. Since 2004, he has been a partner and is CTO of Secure Network, a firm specializing in information security training and consulting based in Milan. Today, he will be presenting his presentation entitled 360 Degrees Anomaly-Based Intrusion Detection. Join me in welcoming Dr. Stefano Zanero.
Thank you. Well, actually, that was a very, very long introduction. I will shorten it to the fact that I'm Italian, so I don't speak a very good English, which makes up for an excuse for everything you will not understand in my talk. And please, if I'm talking badly and you don't understand me, or you don't understand something because you want to ask a question, just feel free to interrupt me at any point. There's no need to wait for the Q&A. If you want to wait, that's fine, but if there's something that you missed and you want me to re-explain something, please feel free to interrupt me during the talk. Basically, what I will do today is try to give you an overview of what we are doing at the Politecnico di Milano in the field of unsupervised learning and anomaly-based intrusion detection. Basically, intrusion detection is a way to try to answer to a very big problem, which is known in warfare as the defender's problem. Basically, the problem can be stated as simply as, while the defender has to defend everything, the attacker needs just to find one weak spot in a plan in order to succeed, which is very well known in all the areas of fighting, of sports, even in chess. There are no defensive chess players, because in order to win a chess game, you have to attack the opponent. Here, the problem is that you have to actually act sensibly. If you attend a 2-day conference such as this one, where a lot of good speakers give you insight on all the ways that you have to attack systems, you might be scared by the sheer number of vulnerabilities that haunt today's systems. And being scared is exactly the wrong approach to the problem. The right approach to the problem, as I think the actual status of the actions against terrorism underline nicely, the actual point in defending is acting sensibly, is not overreacting, is not acting driven by fear. So I advise you to buy a book which is Beyond Fear. It's written by Bruce Schneier. It's probably the first computer security book that any computer security practitioner should have on his shelf, in my opinion. Here I like to point out that there is a Murphy law which describes very well the status of computer security. The only difference between systems that can fail and systems that cannot possibly fail is that when systems that cannot possibly fail, they usually are impossible to repair and usually have devastating consequences because they are failing in a manner that you did not foresee. So the idea is that you have to plan for the worst. So you have to plan not for what happens if your systems are broken into, but for what happens when your systems will be broken into, because they will be broken into at some point in the future. And have probably already been broken into at some point in the past. I don't want to try to ask you how many of you have had a system which has been broken into, because then there will be two types of people in this, in this audience. The people who raise their hands and the people who are lying, either knowingly or unknowingly. Because every type of system at some point in the past or at some point in the future has been or will be compromised. So we must take lessons from what engineers have done for hundreds of years with machinery, with buildings. You have to build things that fail gracefully, where something is not essential and cannot be a total failure if something fails. You must build things that can be recovered. You must have backups and backups of the backups and so on. And you must build things that are tamper evident. Computer systems are not tamper evident. If someone breaks into your computer systems, there are good chances that you will never notice. So what is an intrusion detection system? An intrusion detection system is not the software package that you buy from your software vendor. An intrusion detection system is actually a system which is able to detect tampering with your computer systems. So if you buy a software package which performs intrusion detection analysis and you don't look at it, that system is not an intrusion detection system anymore. An intrusion detection system is software, hardware, and humans cooperating to detect intrusions. So a network administrator such as any of you looking at system logs is a better intrusion detection system than any instance of Snort left running, never updated, and never looked for. The question is, what type of intrusion detection systems do we need? There is a big taxonomy in intrusion detection between anomaly detectors and misuse detectors. If you have, you have probably heard of this, but if you have never heard these two terms, it's because misuse detectors actually exist, and anomaly detectors actually do not exist, except in books, research projects, and a very, very limited number of products out there. There's a very good chance that even if you have an intrusion detection system at, in your company or in your organization, you have never even heard of the fact that there exist two different types of approaches to anomaly intrusion detection. Misuse detectors are the traditional kind of intrusion detection system that you may be used to. They are systems which have a knowledge base of attacks, of well-known attacks, and which look at different sources of data in order to try to catch those types of attacks, which is very, very similar in conception to what your favorite or non-favorite antivirus product does for viruses. The only problems are that, first of all, while when a virus propagates, sooner or later, the guys from F-Secure, if you have heard Mikko Iponen talking today, or from another company, will see that propagating and will create a signature for that. If someone creates a zero-day vulnerability, and since they are very, very evil, they don't even sell it on Wabi Sabi Labi. They don't even sell it on the IRC. They just keep it to themselves. So that's a true zero-day. Chances are that no one will ever write a signature for that vulnerability. So no misuse detector will ever be able to catch that exploit because there's no knowledge base to act upon, unless for some chances an old signature for another vulnerability casually catches also this vulnerability. But that's just a game of luck. The second problem of misuse detectors is the problem of polymorphism. Now, catch correctly what I mean when I talk about polymorphism, because I've been bashed, not rightfully, by David Maynor on this point on his blog. Polymorphism here is not intended as in the expression polymorph virus. A polymorph virus or a polymorphic shell code is just a virus or a shell code which randomly or semi-randomly mutates in order to try to avoid detection. When I'm talking of polymorphism of attacks, I'm talking of the fact that if you give the same vulnerability to exploit to all the people who are participating in the CTF out there, they will exploit it in different ways. Sometimes there will be a key point which is similar among these different ways. And you can catch that, create a signature on that. And you can catch all the different variants with just one signature. But on other attacks, there is no such key stepping point. And so you are left with the option of writing basically one signature for every known way of exploiting a vulnerability. Which means that if someone comes up with an ingenious new way to exploit the same old vulnerability, chances are your misuse detector, no matter how good the guys that are writing the rules are, will not be able to see that. On the other hand, anomaly detectors are the earliest idea of how an intrusion detection system should work. Intrusion detection was first described in 1980. In 1980, I was 1 year old, if this is of any use to you, to gauge how many years have passed since then. And when it was first described, it was introduced as anomaly detection, or the detection of anomalous activities over the networks or over the computers, actually, at that point in time. The idea is that if you're able to describe and to model the normal behavior of your computers, then at any time something anomalous happens, you can fire an alarm. And since attacks are usually intended to make your computers do something that they would rather not do in normal conditions, then attacks show up as anomalies, which is a great idea theoretically, but practically it's a couple of different limits. First limit is, how do you describe normality for a computer system? How do you measure it? Is the number of outgoing packets versus the number of incoming packets a constant which you can measure? Maybe so, maybe not. For some computer, it certainly is. The average number of emails a computer sends, a client sends on a network. If you're working in a company, those numbers are substantially stable, except during Christmas season, for instance, when people usually shoot unwelcome greetings and postcards and e-cards to everybody they know. So it's very difficult to find the variables that describe normality in a computer system. It's even more difficult to create models that can actually model those variables and catch variations and not generate tons of false alarms. Because this is the key difference between a misuse detector and an anomaly detector. The misuse detectors, the intrusion detection systems you work with commonly, do not have, read my lips, do not have false positives, or they rarely have false positives. Why is that? Because if a rule fires, chances are there's an attack ongoing. Even if you don't care about it, even if you didn't want to know about it, that's exactly a packet which matches with the rule. Maybe you activated a rule that you didn't want to activate, and that's your fault. But